Hey guys, Darian Giuseppe here, back again with another video for the Key Concept series. In today's video, we're going through the solution for another question. This question is based off of Taylor series expansion, and this is seen in module 1. No, not module 1. It is seen in module 2 of Pure Material 2. So with that said, let's get straight into this video. We're looking at part 1 first. Part 1 says, obtain the first 4 non-zero terms of the Taylor series expansion of cos x in ascending powers of x minus pi on 4. So with the Taylor series, they normally tell you that it is centered at a point x is equal to something. In this case, or in this part I, it's not telling you where it's centered, but you could kind of guess that is centered at x is equal to pi on 4 because they want you to express cos of x in terms of ascending powers of x minus pi on 4. And what should come to mind is the general form of the Taylor series expansion, which is if the function is f of x, then it can be expressed as f of a, where a is the value that it is centered at, f of a plus what? X minus a by f prime of a plus x minus a whole squared on 2 factorial plus, nope, not plus, by f double prime of a plus x minus a whole cube on 3 factorial by the third derivative of f of a plus dot dot dot. This is continuous, it goes on to infinity, right? So this is the formula that should be coming to mind where the Taylor series expansion is concerned. And then, well, the first thing that you do, right, in the setup of this question is actually to find the derivatives, right? So again, just like the Maclaurin series expansion question that I did, right, you need to find your derivatives. That is key. First derivative, second derivative. Well, we don't know how much derivatives you would need to find. They say the first 4 non-zero terms, and it's cosine into play here. So it is looking as though we may have to find, if it's the first 4 non-zero terms, it might actually be these terms we have to find, these first 4 terms. So you might have to find or find 3 derivatives of the initial function, which is cos. So my first thing would be to write down the function and then start to find the derivatives. So we could let the function be f of x, right? So let f of x be equal to the function, and then we could start to find the derivative, right? So the first derivative of cos of x is negative sine of x, and then if we find the derivative of negative sine of x, we should get negative cos of x. And then lastly, the third derivative, right, or the derivative of negative cos of x would be positive sine of x, because the derivative of cos is negative sine, and the negative signs will multiply by each other to give you a positive here, which is understood. And that is basically your derivatives. This should be good enough. Now we have to plug in pi on 4 into here, 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 and here, because they want us, or they told us to find the expansion in terms of ascending powers of x minus pi on 4. And that, by them telling us this, it is basically they saying that the expansion is centered at x is equal to pi on 4. So that is how we know our value of a in the initial Taylor series expansion that I went through. Yeah, that's how we know the value of a there. So we just plug in that into f, and we plug it into the other derivatives as well. So when you plug it in, you should get pi, the square root of 2 on 2, right? Make sure your calculator is in radians, and yes. So then the next one, when you plug this in, you get negative root 2 on 2. Actually, for all of these, you will get root 2 on 2, right? It's just to make sure you remember your sign, right? Don't forget your signs. So this would be negative root 2 on 2, and the last one would be positive root 2 on 2. So we have what we need here. we just have to take this now and substitute it in the formula into the formula for the Taylor series expansion. So we need to use the Taylor series expansion centered at x is equal to pi on 4. And what we will get is this here. So we just plug in the pi on 4. There's the general setup here. And I would step up to the term now we need. Remember, it's the first 4 non-zero terms. So that would be 1, 2, 3, 4, right? So that should be good there. And then all we do is substitute these guys. This will go here. This will go here. This will go here. No. It will go here. And then this last guy here will go here. So that's the substitutions they're making. And this is what we will get here. And we can just reduce the factorials a bit and it will boil down to this, right? So when you reduce your factorials, you will get this and this here, right? So just make sure that is good there. Stop the video, check it out. And what do we do next? That would be the question. Actually, this looks like this is the final answer, you know. This looks good. If you wanted to, you could probably factorize out the square root of 2, but this is good. This would be good for me personally. And then we have to look at question 2. Question 2 says, or part 2 here says, hence calculate the approximation to cos pi on 16. So whenever they say hence, as in the previous question I did on Maclaurin series, hence means use the information from the previous part. So to approximate cos of pi on 16, you could actually plug in plus, you could actually plug in cos of pi on 16 into your calculator and get the exact answer. But you would get that wrong because the question says hence. That means you have to use the information from the previous part. So what is that information? That information is this, the expansion of cos of x, right? Centered at x is equal to pi on 4, right? So what you would simply do or need to do is wherever you see x in the expansion, you substitute pi on 16 and just plug this entire thing into your calculator and you will be able to get cos of pi on 16, the approximation to cos on pi on 16. So this is our part 2 here, right? Cos of pi on 16. This is our hence moment, as I like to call it, the moment where we use the information from part 1 to get the answer for part 2. So this is it here, and you notice wherever I had x, I replaced it with pi on 16 in this line here. Take a look. Pi on 16, you would see it here, pi on 16 here. That's basically what I did. And now you are taking this entire thing here, plug it into your calculator, and you should get a final answer, which we could approximate to 3 significant figures, because at the top of the cover page on the exam tells you any solution or any answer you get that is not specified in terms of its degree of accuracy. If the degree of accuracy isn't specified, they say to approximate it to 3 significant figures. So we can do that, and when we plug it into our calculator, we will get that the approximation to cos of pi on 16 is 0.977, correct to 3 significant figures. Squiggly line just to make sure that you let them know it is an approximation, right, of cos of pi on 16. And this question, this part 2, is actually this is a application. It is an application of the Taylor series expansion. So that's something to note as well. Right, guys, so this is your solution for part 1. This is your solution for part 2. I hope you guys understood this one. I hope it helped. Feel free to share the video to a friend that you feel it would be helpful to. Like the video, subscribe to the channel, and with that said, I will see you in the next video.